Then next topic is memory transfer. So the operation of memory unit was described the transfer of information from a memory word to the outside of the environment. It is called as read operation. Okay, that is the read operation. The transfer of new information to be stored into the memory is called as a write operation. There is a two operations, read and write. Then memory to outside of the environment is called read operation. Then new information to stored in the memory is called write operation. Okay, and a memory word will be symbolized as a letter as M. And consider a memory that unit that receives the address from a register is called address register. That is, AR is called address register, DR called as a data register. Okay. And it will be address symbolized here. The data are transferred to the other register is called data register and symbolized by DR. So see, the read operation can be stated as DR to the M of AR, and write operation transfer to the content of a data register into the memory. M is selected to the particular address and assume that the input data are the register R1 and address is n. Rn is the will be operation will be stated as M of AR2 R1. And type of micro operation, that first one is the register transfer micro operation, arithmetic micro operation, logical micro operation, and shift micro operation. These are the different type of micro operation. The first one is register transfer micro operation, arithmetic micro operation, logical micro operation, and shift micro operations. Okay. And in arithmetic operation, C, R1 plus R2 to R3 is content of R1 plus R2 transferred to the R3, and content of R1 minus R2 transferred to the R3, then complement of content of R2 is transferred to the R2, and 2's complement of content of R2 is the R2, and R1 plus 2's complement of R2, and increment the content of R1 by 1 R1 and decrement of content R1 by 1. It is a symbolic designation of the arithmetic micro operations. See, a micro operation is an elementary operation performed with the data stored in registers. The micro operations most often perform the data that micro most often to the digital computers are classified into the four categories. The first one, register transfer micro operation, transfer to the binary information from one register to another, and arithmetic micro operation perform to the arithmetic operation on numerical data stored in the register, and logical micro operation perform with the manipulation operations on non-numeric data stored to the other operation, and shift micro operation perform the shift of the data stored in registers. And the register transfer micro operation does not change the information, and when the binary information move from source register to the destination register, it will not be transferred to the, that will not change to the register. The other three data micro operations change the information contained during the operation. See, in the arithmetic micro operation, the basic arithmetic operations are addition, subtraction, increment, decrement, and shift. Okay, in arithmetic micro operations are designated by the statement R1 plus R2 to R3. Then it specifies the add micro operation. It states that the content of register R1 added to the content of register R2, then it will be transferred to the R3. Okay, then to implement the statement of the hardware, we need three registers and the digital component that it performs the addition of the operations. The other basic arithmetic operations are, these are R1 plus R2 R3, R1 minus 2 R3, R2 complement R2, R2 2's complement R2, R1 plus 2's complement R3, R1 increment to R1, decrement to R1. Okay, and the subtraction is the most often implemented through the complements and addition instead of using the minus operator, and we can specify the subtraction of the particular instructions. Okay. Then R2 bar is the symbol for the complement of R2 and add with 1 to the complement it produced to the particular application of the adding to the content of the R1 to the 2's complement of R2 is equal to the R1 minus R2, and the increment and decrement micro operations symbolized by plus 1 and minus on other operations and implemented with the combination of circuit or with the binary up and down operations. Okay, these are the different type of arithmetic micro operations: addition, subtraction, complement, increment and decrement. Okay, these are the different type of arithmetic micro operations. The next one is the binary adder. To implement the add micro operations with the hardware, we need the registers that hold the data and digital component that perform the arithmetic adder. In the digital circuit that form arithmetic of 2 bits and the previous carry is called full adder. The digital circuit generates the arithmetic sum of the two binary addresses of any length is called binary adder. Okay, so the binary adder is a constructed with full adder circuits connects to the cascade with the output of the from one full adder connect to the another input carry of the next full adder. Okay, so A0 B0 added, then it will, if any carry it will be add to the A1 next full adder. If any carry it will go to the next adder, it will carry to the adder and carry the 4, that is S0, S1, S2, S4, the 4-bit binary adder. So for example, A equal to 1 0 1 1, B equal to 0 0 1, that is A0, A1, A2, A3, then B0, B1, B2, B3. For example, A01, B01, 1 1 means 1 0, so 1 is the carry, it will add to the A1. Here store the 0, here 0, here go for 1, here 1, here 1. If there any carry, it will be overflow. Okay, so in that way we can use the full adder. So if you have any carry, it will using a full, it will transfer to the another one. Okay, that is A0 B0, A1 B1, A2 B2, A3 B3. For example, 1 0 1 1 0 0 1 1, that is 1 1 means 1 0, so 1 is the carry, it will transfer to the next one. So here 1 1 1, that is 0, like 1 1, that is 1 transfer to A2, here 1, and here 0 0, it will be 1 added, then 1 is produced to the here, and here A3 is 1, B3 is 0, comes to the 1. That is, the answer is 1 1 1 0. In that 4-bit binary adder, the argument bits of A and the added bits of B are designated by the subscript number of the from right to left. The carries are counted in a chain to the full adder. The input carry of the binary adder is 0 and the output carry is 4. Okay, so likewise we can use the binary adder. Okay, so example is 1011 0011. If any carry, it will transfer to the next adder. If there is no carry, automatically it will produce to the output. Okay. Next one, binary adder subtractor. The subtraction of binary numbers can be done most conveniently by the means of complements. Okay, the subtraction A minus B can be done by taking the 2's complements of B and adding it to A. The 2's complement can be obtained by taking the 1's complement of and adding to the 1. So, and the least, here we can use the full adder, one is the another one, the least significant bit of the pair bits. So addition subtraction operation can be combined into one common circuit by including the exclusive OR gate. Here is the one of the exclusive OR gate. Okay, with each full adder, in each full adder we can connect the one exclusive OR gate. Okay, here the mode of input M control the operation when the circuit is an adder, and when m equal to 1 the circuit becomes a subtraction. So when m equal to 0 we have b plus like b none of 0. The full adder receives the value of b, the input, and the circuit performs to the a plus b. When m equal to 1 we have b none 1 equal to b complement and c naught equal to 1. Then the b input all are complements and a1 is added to the input of carry. It is called as a binary add subtractor. Okay, in each and full adder we can add the one exclusive or, then the control inputs are m equal to 0 and m equal to 1. Then we take m equal to 1 the circuit becomes as the subtractor. Okay. Next, binary incrementer. The binary incrementer micro operations adds 1 to a number in a register. So for example, if a 4-bit register has a binary value 0110, after it is incremented it goes to 0111. This micro operation is easily implemented with a binary counter, that is a half adder. Okay, see, in every time the count enable is active, the clock pulse transition is incremented to the register by 1. So A0, A1, A2, A3. There may be occasion when increment micro operation must be done with a combination circuit the independent of particular registers. This is can be accomplished by the mean of half adder. In this above diagram, one of the input to the least significant bit, the half adder is connected to the logic 1 and other input is connected to the least significant bit of the particular number of the incremented. The output carry from the half adder is connected to the one of the input of the next high adder of the half adder. The circuit receives the circuit receives the 4-bit from A2 A3, that is A1 A2 A3, adds 1 to its generate the incremented output and so to the S3, that is S0, S1 and S2 and S3. It is called as a 4-bit binary incrementer. When you have to increment any one of them, you can go for this binary incrementer. Next one is the arithmetic circuit. So the arithmetic circuit in micro operation can be implemented is one composite arithmetic circuit. That basic component of an arithmetic circuit is the parallel adder. By controlling the data input to the adder, it is possible to obtain the different type of arithmetic operations. We can addition operations, subtraction operations, we can do everything will be easier. See, the diagram shows the 4-bit arithmetic circuit. It has the full adder circuit that constitutes the 4-bit full adder, and the 4 multiplexer for choosing the different type of operations. There are two 4-bit inputs A and B. That is, and A is a 4-bit. The 4 inputs A go directly to the X inputs. Okay, and binary adder, each of the 4 inputs of B are connected to the data input to the multiplexers. Okay, and multiplexer data input here, that input data also receive the complement of B. The other 2 data inputs are connected to the logic 1 and logic 0 is fixed voltage, and logic 1 signal can be generated to the inverter whose input is 0. It is here. The 4 multiplexers are connected controlled by the two selection inputs, that is S1 and S0. The input carry and to carry input of the FA, that is a full adder, that is it will be added to the full adder. Then the least signal position, the output of the binary adder is calculated from the following arithmetic addition, that is D equal to A plus Y plus Cin. Here select S1 S0 Cn, that is input is Y, that is D equal to A plus Y plus C in. It is one of the micro operations. See, if S1 S0 0 0 C in is 0, then input is set to the B, then D equal to A plus B. If 0 0 1, it will be selected to A plus B, that is add with carry, and 0 1 0, it will connect with the B complement, that is D equal to A plus B bar, that is a subtract with borrow, and 0 1 1, it will come to the A plus B bar plus, that is subtraction, and 1 0 0, that equal to transfer to data from A, and 1 0 1 to the increment of A, and D equal to A minus 1, that is decrement of A minus 1. Okay, in here we can use the, in this arithmetic circuit we can implement the number of operations, that is addition, subtraction, increment, transfer, decrement. Every operation will perform the in only single arithmetic circuit. Okay, see here the arithmetic circuit function table. Select S1 S0 input Y, output A plus Y C in micro operation. 0 0 0, that equal to A plus B addition, and 0 0 1, that equal to add with carry, and 0 1 0, that is subtract with borrow, and 0 1 1, that is subtract, and D equal to 1 0 0, that is transfer to A, and 101, that is equal to increment A, the next 110, that is decrement A, then all are ones, that is transfer of A. So here in the arithmetic circuit function we have to perform different of micro operations, that is add, one of the operation, add with carry, subtract with borrow, subtract, transfer A, increment A, decrement A, and transfer A. So different type of micro operations we have to perform in a single arithmetic circuit function. Okay, see here selection of the inputs S1 and 0 C in. All are zeros, add 0 0 1, add with carry, 0 1 0 subtraction, 1 1 subtract, 1 0 transfer A, 1 0 1 increment A, 1 1 0 decrement A, all ones are transfer of A. Okay, so all the operations performed in the particular single arithmetic circuit. So the output is D equal to A plus Y plus C in. Okay. 4 multiplexers and 4 adders. Thank you.